Alright, this is classic projectile stuff. This is what I like to do. Alright, so like always, we should draw the scenario first. So if we're trying to throw a ball upwards off a bridge, or I think we've done questions where we had a cliff, draw the scenario out. So what I have here is the height, okay? And I guess the bridge, I put a platform there. That's my bridge, and then it's going to go into the water eventually, right? So we're going to throw it upwards. It's going to go up for a little while, and then it's going to go into the water. So the question's asking, like, what's the initial height of the ball when it's released? Well, that's at the bridge. So we won't count the height of the person, but we'll just put the height of the bridge in that spot there. So right here, what would the height be? That would be at 0 time. So h of 0, I guess, right? So that would be h of 0. So if we substitute 0 here and here, that's just 0. So we have 50. And we also know that in standard form, the constant is our y-intercept. So this is our 50 meter. This is the bridge right here. So I guess we can say that's the bridge. All right. So we're going to launch that ball up in the air quite a ways. I don't know. This is not going to be to scale, but just in general, get the idea of what's going to happen with this. This ball is eventually going to hit the water here, right? So it's going to hit the water there. It's starting here. Not that this matters, but like quadratic-wise, we might come across some values here. Of course, this would be a negative time. So this is time in seconds, right? And then the height here, this is h in meters. Okay, so we're at 50 here, and it's not to scale. So let's forget about the scale part. So the initial height when the ball's released, we know that's already 50 meters, right? So 50 meters already. So how about when it's at 3 seconds? Well, all we have to do is substitute. So for B, h of 3, right? That's 3 seconds is equal to -5 times t is 3 squared plus 40 times 3 plus 50. Okay? So this is 9 times 5 is -45 plus 120 plus 50. Alright, so that gives us a time of, what is that? So that's 125 meters. So this one's 125 meters. That seems pretty optimistic that he would throw it. So that would be like 75 meters high. Alright, cool. This guy can throw. Alright, let's see. C. What would be the maximum height? Okay, so maximum height here. If this was in vertex form, we'd be laughing, but it is not, so we need to find out this maximum height here. That is our vertex. So the axis of symmetry, if it's in standard form, remember axis of symmetry, x equals -b over 2a. So maybe I'll just do that here, and then I'll substitute. To get the height, we're also going to have to substitute the axis of symmetry, the x value. So I'll do that over here. So let's say x equals, so -b, so -40, all over 2 times, all over 2 times a, which is -5. So that's -40 over -10. So x is equal to 4. So 4 seconds. So let's see, that's 4 seconds. Here we go. This is 4. What we want to find is the height here. So 4 seconds, so let's look at C here. h of 4. That will give us our maximum height. And I don't think it's going to go a lot higher because, you know, it starts to slow down and slow down. Eventually it stops and then it's going to come back down, right? So equals -5 times 4 squared plus 40 times 4 plus 50. All right, so that's 16 times 5. Let's do this part here. So this is what? 160 plus 50. So together that is 210. And then this is it's going to be 80, negative 80. All right. So when we combine all of that together, it comes to 130. Yeah, so it only went 5 more meters from in the last second meters. All right. So this is the maximum. The maximum height would be 130 meters. That's what the maximum. Okay, and so now let's think about, okay, we know what when we started, but when it hits the water below, how long is that going to take? So those are our roots right here. So that's right here. It's going to splash and hit the water here. We're probably going to get a root back here, and of course that does not count. That's not part of the scenario, so we'll have to rule that out because it's going to be negative time. All right, so we know at that place the height is 0 because it hit the water. So 0 is equal to negative 5t squared plus 40t plus 50. Okay? And then let's just divide everything by negative 5 because I think we're going to be able to factor this. Or at least I hope we can. I don't know. So let's see. It's going to be t squared minus 8t minus 10. So let's see if we can factor this. Well, the factors of negative 10, so yeah. This one might not factor too nicely. Let's just, we might have to use quadratic formula or something. Alright, well that's okay. So let's do that. Negative b, so we have just 8 plus or minus the square root of let's see, negative b, so b squared, which is 64, minus 4 times a times c, all over 2. Okay? So what is this? We have 64, so 104. So 8 plus or minus square root of 104, all over 2. That's obviously not a perfect square, but it's really close to 10. You know, it's like super close to 10. Not quite. So what it works out to is negative 1.1 or 9.1. If I round to the nearest tenth of a second, okay, which is pretty reasonable. So we're going to rule out this one right here. This is the negative 1.1. So this is here. This is at 9.1 seconds. And to think about if that's reasonable, it was 4 seconds to get to half. That would be about here, right? So this would be about 8 seconds. And then another 1.1 seconds. Or you can see here the negative 1 seconds. You can see the symmetry, right? So that's reasonable. Okay, so we're going to say approximately 9.1 seconds. All right, so again, like just piece by piece, put it together, set up a diagram, use all the tools that you have. There may be other ways to do this as well, but all right, good job.